So, good afternoon. As Doug said, my name is Don Briton. I'm the Meteorologist-In-Charge at the National Weather Service office in Great Falls. I was stationed at Malmstrom Air Force Base as a weather observer back in 1976, so this is my 40th year in meteorology. And I've had a lot of different positions, and over the past few years I've been a meteorologist in charge, which means that I do a lot of things like travel orders and payroll, and things aren't as fun as this. This presentation, however, will not be as technical as the ones that we saw this morning. This is going to be more of an overview of some of the products and services that we provide, including the backcountry forecast. So I hope that you don't find it too boring. So one of the things that we've done in the past, when we've done warnings for winter storm type events, our criteria for whether we issue a warning or not has been based upon whether we thought, for example, we would get 6 inches of snow over the course of 12 hours or 8 inches in 24 hours. And as you all would know, maybe 6 inches of light fluffy snow in the middle of January, early February is not the same thing as 6 inches of snow in October or March or April. And so we're trying to move away from these so-called thresholds of some certain amount that would cause us to issue a warning or that kind of thing. We're looking more toward how the snowfall would impact you. So it's entirely possible that an inch of snow on the right temperature of pavement near rush hour could be more impactful than 6 inches of snow in the middle of the night in January, for example. So we're moving more towards that to help decision makers, including people such as yourselves, to be able to make informed decisions about what we think the impacts actually would be, as opposed to merely the amount of wind or snowfall that we get. So one of the ways that you can help us is if you get snowfall reports or that kind of thing. The more information that we have, I think we talked about the problem of data earlier today, and so the more data that we get, the better we're able to figure out what's going on. And although we have more sensors in Kyrgyzstan, we still could, it's a big state, and so all the information we get is of great use to us. So we would encourage you to call us and let us know what kind of snow or impact you have observed, or if you have any concerns about how we can improve our services. If you're a professional decision maker, then you could also become one of our Weather Ready Nation ambassadors. What's Weather Ready Nation? Well, it's an effort to work with the public and other agencies to enhance preparedness and safety, response to weather events, and get the community involved in being prepared. So it's this Weather Ready Nation concept covers a broad spectrum from international agencies like the World Meteorological Organization and other national meteorological organizations, the National Weather Service here in the U.S., emergency management, academia, the private sector, etc. So, what kind of forecasts do we have? Well, we've got forecasts that you can get access to, whether you're on your phone with this example here on the left or in the middle, and then if you're using a regular PC, then you would see a display similar to the one on the right. They both provide roughly the same information. It's for a given point. The forecasts that we do are 2.5 kilometers square. And so in the area that Great Falls is responsible for, we have something like 22,000 of these different, we call them point forecasts. We like our jargon just like everybody else, and so if I say something and you don't know what it is I'm talking about, then by all means stop me and say, what does that mean? So these point forecasts give us the ability to be able to forecast for a very precise point. Also, as we learned earlier today, the resolution of the model guidance has a role in how accurate or how precise our forecasts can be. So sometimes precision doesn't necessarily equal accuracy. So we can have a very precise forecast, doesn't necessarily mean that it's very accurate. So we spend a lot of time trying to make sure that our precision and our accuracy are in alignment. So on our website, if you take a look up across the top, I don't know how easy that is to read, but the tabs across the top have watches and warnings, observations, forecast graphics, rivers and lakes, climate, fire weather, detailed hazards, and recreation. So there are a lot of different things that you can get on our website. In this particular case, this map was from yesterday, and this map is showing that there was a high wind warning in effect for areas east of the continental divide on the plains in the wake of that low pressure system that moved off. So here's a point forecast for Lone Mountain, and we can see from this we have icons that kind of describe the weather. How well it describes the weather is up to you to decide. This is one way of being able to look at it. Another way of looking at the forecast, and one I think that can be very useful for the people here, is looking at this graphical presentation. And one of the things I would point out is that if you look up here, it's not probably very easy to see. When we do a POP forecast, everybody's familiar with the term POP, probability of precipitation. They talk about it on the news, TV weather guys talk about it and that kind of thing. But the probability of precipitation is the chance that we will get 1/100th of an inch of precipitation. Why 1/100th of an inch? Because when we started making scientific measurements back in the late 17 and early 1800s, we measured everything as fine as we possibly could. So we have a tendency to measure with a micrometer, mark with chalk, and cut with an axe. But this 1/100th of an inch of precipitation would probably be just about meaningless for almost any human endeavor. It's about the thickness of a playing card. So if you took a playing card and felt how much that is, that's not a lot of precipitation. So 1/100th of an inch of precipitation may not actually have any impact on you at all. But what we can do up on with this graph here is we can change this quantitative precipitation forecast and find out what are the chances of getting 1/10 of an inch or 1/4 of an inch, 1/2 of an inch. Okay, we can do the same thing with snowfall. So maybe 1 inch of snowfall doesn't interest you, but if you want to know what the chances are of getting, say, 6 inches of snowfall, well, that might be something that would interest you more. So I would encourage you to, if you use our webpage, and I hope that you do, you're paying for it. So if you look at this page, if we go back at the bottom, well, you can't see it, but at the bottom down here where it says additional forecast and information, there is an option for a graphical forecast, okay? I think maybe it's this hourly weather forecast here as well. And also, if you want a more detailed explanation of why the forecast is what it is, we have a forecast discussion that's issued at least twice a day. Sometimes it's updated more frequently than that, where the meteorologist who creates the forecast puts down what their reasoning is behind the forecast. So if you're interested in that kind of thing and you like a little bit more of a technical explanation of the forecast, then we've got a product for you. So here's another look at our website, and if we take a look at the detailed hazards page, we would end up with something that looks roughly like this. This is kind of zoomed in on the western half of Montana, and what you can see, maybe not clearly, is a surface observation plots. I don't know if any of you are familiar with that type of presentation, but there is a method to that madness, and if you don't know how to read those, you can give us a call or you can look it up online and see how to make sense of that. This is taking a look. We can overlay on here. We can overlay radar data, for example, and we could also say instead put the wind forecast. This is from yesterday. If we took a look at this in real time here, so here we have some weather observations that are current. If I take a look here at surface observations, open this up and say I want to set the gust threshold to, I only want to see gusts that are 50 miles an hour or more. That's about 50 miles an hour. Well, right now there aren't any gusts that are 50 miles an hour or more, so let's take a look at maybe some gusts that are around 40 miles an hour. So there are a handful of gusts that are around 40 miles an hour, and so it gives you a chance to be able to sort of filter out some of the data and find out what parts of this are significant to you.
Is that a gust every 5 minutes, or what's the time frame on that?
It depends upon how often that particular sensor reports. So if the sensor updates every 5 minutes, then that's what you would get. And like I showed before, we can also overlay high-resolution hazards. If we take a look here, we see that Fort Peck Lake has a high wind warning because of waves on the lake. And we could also overlay the NexRad radar data, and we see that we have that up there, but there's very little there other than some noise. It looks like a little bit of reflectivity off of the mountains. Chris talked earlier today about the issue of the radar beam overshooting things. Let me give you an example of how that might look. The radar in Great Falls is about 150 miles from Bozeman as the crow flies. And what that means is the center of that beam, you can see as it goes out, obviously the beam expands, and the center of the beam here is at 25,000 feet, about 24,000 feet. So that's overshooting a lot of lower level stuff. So it's, we're getting close to being almost invisible there at this range. And that's at the lowest elevation that we have, which is 0.5 degree. Okay, so let's go back to our presentation, already in progress. So we also have this recreation and safety forecast. And this is kind of what the page would look like. And you can narrow it down by selecting these different types of activities that you might be interested in. And we can go to our web page and take a look at a live version of this. So this is the web page. And we could say, well, if we just look at this area right here, along the Madison Range, click on this. And these are all the different areas that we have. And we could say, well, let's get a forecast for double slide, and we might have to scroll over to be able to see it, and it's going to get in the forecast. And so this is the forecast for that particular point that you might find interesting. We also have fishing and camping and lots of other recreational activities that we have forecasts for. So hopefully you will find some use for that. This is just an example of what that forecast might look like. We also do what we're talking about. I mentioned the concept of these impacts earlier and how some weather event could impact some activity. It could impact one activity and not another activity, and so we don't always know exactly who the end user is of these things because our audience is, all American taxpayers. So what we have is, in trying to support the decision-making process for those people in decision-making roles, we have an email notification. So if you're a professional decision maker and you would like to get information from us, some advance notice that we think something's happening in the future, or it looks like the storm may be coming, but we're not really sure yet about exactly how much precipitation we might get or how much wind. So we can give you some idea of our confidence level with a notification like that. We also do weather stories, and we've even sometimes take a look at, and we include your backcountry avalanche warning to help sort of propel that information over a broader audience. So we have, if we look at our backcountry forecast, we have over 20 different mountain weather forecasts that include things like cloud cover, high and low temperatures, wind, precipitation, and type, how much precipitation we think that we would get, and that kind of thing. So hopefully that would be another product that you might find useful, and you can find that on the left-hand side of our menu under recreation and mountain snow forecast.
Hey Don, you email that to us every morning. Is that available for the public to get emailed every morning? Can they sign up for that? Or
not the public, but professional decision makers from other agencies and that kind of thing, yes. Okay. So if you want that, just let us know. So these are all the parameters, or some of the parameters that are shown in this text product that's for an entire range. So as opposed to being just a point, it tries to sort of average things over an area, and obviously there are things get smoothed out and some detail gets lost when you average over an area, but it's a good overview of what might happen in a certain mountain range. If you're interested in looking at the data yourself and coming up with your own forecast, please don't compete with us, but we don't need any more competition. If you're interested in that, then we have the high-res rapid refresh model that is being done. It updates every hour. It goes out for 24 hours with hourly forecasts, so you can find out what would happen at 11, 12, 1 p.m., 2 p.m., that kind of thing. And there is, obviously, we spend a lot of time studying and learning how to interpret these models. So I think we're pretty good at interpreting these, but it doesn't mean that you couldn't have some fun taking a look for yourself at what the basis for the forecast is. So if you wanted to take a look at those, you can go to ruc.noaa.gov/HRRR, and you could access the same model data that the forecasters are using at the forecast office. We're also trying to spread out and to get our message out and to be able to support decision making. We're trying to reach out in lots of different vectors or avenues. And so social media is obviously one of those. So we do YouTube presentations every Monday morning. We create like a minute and a half sort of an overview of what's going to happen across the state. We publish that video. We've got all the Montana offices, which are located in Glasgow, Billings, Great Falls, and Missoula, have Twitter feeds and Facebook pages that we try to keep updated with the latest information, and hopefully maybe have a dialogue where people can provide us information and ask questions and we can respond and that kind of thing. So that may be something you're interested in as well. So that concludes the presentation. I hope I didn't bore you too badly. And I'm sorry about my voice. I feel like I'm getting maybe a little bit of a cold or something. So, any questions? Yes?
So Don, I always wondered, what are those point forecasts that you guys have? What model is that? Is that GFS?
Well, we don't rely on one model. So the forecaster would look at, if you're familiar with modeling, there are a number of different models. Chris mentioned some earlier today. You mentioned some. We had the European Community Model. There is the, which we actually have to pay for, the European Community. All of the members of the European Community have to pay for it. So if the United States use it, we have to pay for it too. So, but we have just limited access to that because we don't want to pay for the full suite. So we have also the Global Forecast System, which is the GFS, if you're interested. There's a North American model. So there's a number of models we put together. Now, it turns out there is some value in taking a lot of these models and averaging them together to develop what we call a consensus forecast. One of the things, this might be interesting to you, maybe it isn't, but this is a little bit more technical. So, you know, everybody has a PC, I'm sure, and there was a time when your PC had a single processor on it. And they kept upping the clock speeds, and everybody's familiar with, oh, I gotta get a faster computer, so a higher clock speed. And what happened was they started hitting the wall on what they could do with clock speed. So they put two processors on there called a dual core, okay? Then it's quad core, and then octa-cores. So because they couldn't keep increasing the speed of the processor, they just make the processor add more processors to the system. Kind of a clever solution to get you to buy another computer. One of the problems that we've had with modeling is if we decrease the spatial resolution to get a smaller grid, or if we decrease the temporal resolution, and in time steps we run the model and then we go out say 30 seconds and run the model again, and we keep doing this to go all the way out. Well, if I want to get a faster computer, then maybe I could do something like decrease the spatial resolution or decrease the temporal resolution, get smaller time steps. One of the problems with that is it starts to get noisy. Okay, there's a lot of things that start happening that don't necessarily make sense, and I think that Chris mentioned models blowing up. Okay, what happens is things just start getting very chaotic. So one of the things they decided to do was, what if instead we took a model and we ran it. Now, of course, a computer model is the sort of the sum of a lot of assumptions that we're making about how the atmosphere works. So we sort of codify all of these assumptions and say, okay, if this is how the atmosphere works, and given these inputs, what do we have for an output? Well, what we can do is we can change some of these assumptions and change some of the inputs and tweak it and then run it again. And we can do this several times. It's called an ensemble forecast. And so what we can do is take a look at what happens after we run 20 different, they call them perturbations. If we run through 20 different perturbations, how many different solutions do we get? If the solutions all come out to be pretty close, we have a high confidence that the models are handling things correctly. If they diverge more and more over time, then that does not necessarily help our confidence, because now it could be a low pressure system there, could be a high pressure system there. So that's what we're trying to do. So when you say, what models do we use? Right now, we're using a lot of ensemble stuff. Any particular model, if anybody's interested in modeling type stuff, any particular model, even when we make these changes, is what we call under-dispersive. It doesn't deviate enough from the original. So you take different models and you put them all together. Well, trying to push all that stuff down to the forecast office is really hard. So they're doing this stuff back at the National Climate and Environment Prediction Center, NCEP, and we're getting a blend of all of that stuff. And we're finding that it's working really well. And I think that in the future, using the very big computers, that we're going to find more and more of those forecasts are going to get accurate. I'm sorry if that was a long-winded answer.
For each of those 22,000 grid points that you have in your forecast area, the forecast that you give, you click on it, is that an ensemble forecast? Or is that?
It's the forecast that the forecaster decided was the best solution to the problem at hand.
So it varies each?
It could vary each time. It's getting to be, these models are getting better and better, and over time it's going to be more and more difficult for the forecaster to be able to make decisions like that, I'm afraid.
So the lead forecaster is the one that's determining which one they're going to go with for the grid forecast?
Yes,
Okay.
and for a particular time and for a particular element, because you might believe that a model A might handle the winds really well, but you don't like the way it's handling precipitation, and you might change that on day 3, for example.
Thanks.
Anybody else? Yes?
So looking at your backcountry forecast on a pretty regular basis that you email the Avalanche Center
Okay.
and other areas, it seems to be often different than your point forecast on your NOAA site. Like it,
That's right, and it would be, because it's not a point. So when we take, say, imagine we had a mountain range that encompassed 300 or 400 different grid points. And then we try to average that. Well, how do you average it? Just take a mathematical average of them, or do you try to average them based upon height? Do you bias it towards the extremes so that you're getting a bigger range? Do you try to find the median? And so it is definitely going to be different from a given point in that area because it's averaged. So we use a lot of statistical processes to be able to do that. The computer does, I do. Anybody else? Yes?
Well, Doug asked you about an email, but the public can get that information by clicking on Snow Avalanche.
Yes, absolutely. Yep. Anyone else? All right, thank you very much for your time. Have an excellent day.